Woohoo! Chain rule day 2, assignment 48. So, yes, we really do need to understand how to do this notationally. Like if y equals f of x is um, secant of 3x squared plus 1, I need you to be able to think about this as there's an outside function, and then there's this inside function of x. And so we need to be able to uh, take the derivative here. We know if we take the derivative of this, we get dy du, because it's in terms of u stuff. Derivative of secant is secant u tan u. And then here, when I take the derivative of this, that's du dx, and the derivative of this would simply be 6x. So I'm looking for dy dx, which means I need to do dy du times du dx. Dy dx is left over. So that's secant u tan u times du dx, 6x. But remember, since we're doing dy dx, we can only have x's in our answer. So we're going to have to replace these u's with what u is equal to in terms of x. So we should have secant 3x squared plus 1 tangent 3x squared plus 1 times 6x. Okay? I understand completely that your brain is much happier to say, I'm going to take the derivative of the outside function and have secant leave the inside function alone, tangent leave the inside function alone, and then come back and take the derivative of the inside function. And look, we're there, and it's so much faster, and I got it. I agree with you. I know. But that first way is the way we demonstrate we know how the car works, not just that we can drive the car. And the AP exam really wants you to understand where all this stuff is coming from. Okay? And so, in that problem, we just looked at doing dy du equals dy dx equals dy du times du dx. But we could also think about this problem, or we could think about chain rule in general, as a composition of functions. So if I have h of x equals f of g of x, and I want to take the derivative of this, I would say that h prime of x equals f prime, leave the inside function alone, times the derivative of the inside function. Okay? I need to be able to understand chain rule, not just in that calculus monkey kind of way where I can chug through chain rule problems, but also have a grounding for that chain rule within a notational frame of mind, or what's really going on here frame of mind. This says the derivative of the outside function times the derivative of the inside function. This says the derivative of the outside function, leave the inside function alone, times the derivative of the inside function. Okay, so you have to be able to recognize this stuff notationally as well, please. All right, so how about this one? I see here this function. Where's my function? I don't like either of those. Okay. Um, 4 sine of x squared. Okay, that's y equals. And I'm going to say, hey, let's let this inside function be x squared. And so this outside function, I guess what I want to call it y of u, would be 4 sine u. And now what I'd like you to do is use this information to help me find dy dx. Okay? See if you can help me find dy dx. No, don't think about it as the derivative of this times the derivative of that. No. Actually do it notationally. See if you can do this notationally. Pause the video, give it a try. Welcome back. So here, I'm thinking that du dx is going to be 2x. And here, I'm thinking that dy du is going to be the derivative of this for cosine u. So if I want dy dx, I know that's going to be dy du times du dx. And in our problem, that's going to be 4 cosine u times 2x. But wait, our answer is supposed to be only in terms of x's. We need to get rid of this u and replace with some x stuff. So 4 cosine x squared times 2x. You know, it's funny because I often think that when I have to do these problems that make me think, you know, notationally, or make me think more about the underpinnings of chain rule, I'm really glad I know how to do chain rule that other way, where I say, take the derivative of the outside function, leave the inside function alone, then come back and multiply by the derivative of the inside function. So I can check to make sure that this thing that I did using this notational approach is in fact the same as what I would expect when I just, you know, went in and followed our little recipe. All right. So how about this way? F of u equals 4 sine u, and g of x equals x squared. And we're looking for um, y prime when y equals f of x. Now, this I don't see here, but I do see f of g of x as a possibility. Yeah, so I want to take the derivative of this. Well, what's that going to be? We know notationally it's the derivative of the outside, leave the inside function alone, times the derivative of the inside function. So with these pieces, what does that look like? Well, here's f, and I need f prime. So f prime, the derivative of this, f prime of u is 4 cosine u. Notice, however, this says that I'm supposed to take that derivative of f and evaluate it at g of x, which means I'm supposed to take this g of x thing and shove it into that u. Okay, so f prime of g of x is 4 cosine x squared, because I'm replacing that. This is f prime of a thing, and I'm being asked to evaluate that thing at g of x. So I put g of x in to all the u's in f of u. Now, what do we need? We also need g prime of x. Here's g of x. So g prime of x is going to be 2x. And finally, this chain rule recipe says I'm supposed to take this thing, 4 cosine of x squared, and multiply it by this thing. And really, in my brain, it simultaneously feels like 4 different approaches to doing the chain rule. I'm sorry, 3 different approaches to doing the chain rule, and yet it all also simultaneously feels like I'm just doing the chain rule. So, yeah, chain rule. It'll be big one day. Okay, so let's try a couple practice problems, and let's just not worry about the notation now. You know, it's good to think about a little day every day. It's good to floss a little every day, but we don't want to floss all day long. So here we go. Y equals secant 3x squared plus 1. Yes, I know we did that. I want to see how quickly you can do it now. 5, 4, 3, 2, 1. No, really, it should go fast. The derivative of secant is secant tangent times the derivative of that inside function, 6x. Okay? That's your goal. Your goal is to get that comfortable with it. Just like when you were little and 6 times 7. Wow, it took you so long the first time to get to 42. Now 6 times 7, 42, no problem. And remember, sine of pi over 6. Sine of pi over 6 is so hard the first week of January. But sine of pi over 6, no worries. 1/2. Okay, so let us practice and practice and practice these things. Y equals 2x sine of x squared plus 1. Find y prime. Okay, I see a product rule. And I think many of you did not see a product rule. I don't know how to get you to see a product rule. Um, this is a product rule. It's a thing times this other stuff. So I have to use product rule here. This times the derivative of that. Derivative of this requires chain rule. The derivative of sine is cosine. Leave the inside alone. Times the derivative of the inside function. Plus this stuff times the derivative of that. Okay, good. All right, let's get more comfortable with it. Y equals 2x squared minus 3x over cotangent squared x. I see Mr. Kukla being just mischievous. So, I don't know. What do you want to do? Do you want to use quotient rule? Do you want to flip it up and have a negative 2 exponent? I think I do. So either we're going to use the quotient rule like this, or we're going to flip this up so that the problem reads 2x squared minus 3x times cotangent x to the minus 2. Or we're going to use product rule here. I prefer product rule. So y prime is going to be this times the derivative of that, 2x squared minus 3x times the derivative of that, which is going to be negative 2 cotangent x to the negative 3. Don't forget to subtract 1 there, times the derivative of cotangent, which is negative cosecant squared x. And really, by this time, so many people are tuckered out. They say, done, moving on to the next problem. But we've only done the first half of the product rule, right? We did this times the derivative of that. Now we need to add this times the derivative of that. So I'm going to have cotangent x to the minus 2 times the derivative of this is going to be 4x minus 3. Okie doke. Okie doke. No, I really don't want to do that one with quotient rule. Come into office hours and make me do it there if you really need me to. All right. How about this one? This is great. Y equals, in that kind of way, like someone drives their car through your bedroom. Like, well, I'm glad I got to see that. I'm glad I wasn't in the bedroom at the time, but that's pretty horrible. X plus cosecant to the third 4x. Oh, the depths of hell we never imagined existed until Kukla showed us them. I often feel like I'm taking students on a journey through the underworld. Okay, y prime. That's a plus sign. I have to do this derivative, I have to do this derivative, and then I have to add those derivatives together. Now, this one, am I using quotient rule, or am I flipping this up and raising it to the negative 1 power? Well, since last time, I flipped it up. This time, I'll just use quotient rule. Low, d high. Now here's chain rule. Outside function, inside function. So derivative of the outside, leave the inside alone, times the derivative of the inside. Are we done? Oh, hell no. Minus high d low. The derivative of this, 2x plus 2. Is that it? Let's see. Low d high minus high d low all over low squared. Are we done? No! Now, plus this. Remember, this is really cosecant 4x to the third. So to the third is the outside function. Subtract 1 times the derivative of the inside function. Derivative of cosecant is negative cosecant, hey, not x, cosecant of stuff. The derivative of cosecant of stuff is negative cosecant stuff times cotangent stuff. And then finally, the derivative of that inside function. Since I ran out of space over there, I'm going to put it over here. Wow. So here, quotient rule plus derivative of this, just chain rule. Not that our quotient rule didn't also require chain rule. Hubba hubba, my grandmother would say. Yes, the same one who said, keep your filthy mitts off this. All right, so one more of these, just so that we're really warmed up before we go to the next page. 4x squared plus 2x. There we go. So, what do you think? Can you do it? Can you do it comfortably? I know you can do it reluctantly. Can you do it comfortably? That's why we're practicing. Okay, pause the video, give it a try, come back when you're done. So I opted to do the product rule version of this. 4x squared plus 2x to the minus 1/2. So my y prime is this times the derivative of that. Bring down that negative 1/2 times, leave the inside function alone. Don't forget to subtract 1. Are we done? No, that's just the first half of the product rule. This times the derivative of that. Now we need to add this times the derivative of that. 3, 4x squared plus 2x to the minus 1/2. And you can see this looks a lot like those GCF problems from pre-calc. And we take out this law of power. And then we'll be able to have this as a factor times a factor that we could then set equal to 0, and we could find out what about y prime equal to 0. Okay, quick, let's move on. You're going to love this. So, y equals f of cow. And cow, not y, but cow is in fact a function of x. Okay? So, I would like to find dy dx in each of the following situations. Okay? Oh, what's the derivative of cow? It's cow prime. Cow prime is the derivative of cow. All right? So find me dy dx. Here's your first problem. Y equals sine squared cow. Oh, mercy. So I'll walk through it with you. You can do the next few on your own, okay? All right, so here we go. I'm thinking about the chain rule. I take the derivative of the outermost squaring function. And what's that going to be? That's going to be 2. Leave the inside alone. It's not cosine, it's cow. Don't forget to subtract 1. Times the derivative of that inside sine function. Leave the innermost cow alone. Times the derivative of cow, which is cow prime. There we go. It may help to take the time to see it that way, to write it that way. Derivative of the outside function, leave the inside alone. Derivative of the next innermost part, leave the innermost alone. And then finally the derivative of the innermost. Okay? Excellent. I think you know what we're doing now. And so now, will you please find dy dx equals sine of cow squared. Welcome back. Y prime equals cosine cow squared times the next innermost function isn't cow, it's the squaring of cow. 2 cow to the first times the derivative of cow. Okay? How about y equals cow to the third? Then what's my dy dx going to be? What's my y prime going to be? Yes, that's right. I bring down the 3. I leave the inside cow function, my cosine, alone. Don't forget to subtract 1 times the derivative of cow. Excellent. So let's go a little further. Hey, you should really, if you haven't been, you should really pause the video and do these last 3 um, on your own. So 1 over cow to the third. Okay, pause the video if you haven't been. Do this problem. Find me y prime. Find me dy dx or df dx. Welcome back. So I thought about this as cow to the negative third. So my y prime is negative 3 cow. Don't forget that's subtracting 1, so that has to be further to the left, times the derivative of that inside function, that cow function, cow prime. Okay? How about this one? Y equals square root of cow. Square root of cow. What would y prime be? Pause the video, give it a try, come back. Hi there. Did you get 1/2, leave the inside alone? Oops, not cow theta, just cow. Don't forget that minus 1/2 times the derivative of the inside cow, which is cow prime. Okay, last cow problem is cow times tangent of cow. Yeah, no kidding. Okay. Welcome back. Did you get a product rule here? So this times the derivative of that will be cow times the derivative of tangent is secant squared, leave the inside function alone, times the derivative of the inside function. But wait, we're not done. It's a product rule. We've just done this times the derivative of that. We still need to do that times the derivative of this. So plus tan cow, tan cow, times the derivative of cow, cow prime. All right. Any questions about that? Fabulous. Last thing I want to look at with you, cow is a function of x. It had to be in our answer because we were looking for dy dx. All right, last thing I want to look at with you is, yeah, we're just going to do it. So let's say I've got this chart, this table, and AP loves tables. 4, oh, sorry, 1 and 4. I have F, I have G, F prime, F G prime. And F of, oh, that's problematic. That's much happier. 1 and 4. Okay, so F of 1 is 4, G of 1 is 3, F prime of 1 is 5, F prime of 5, and G prime of 1 is 2/3. And then F of 4 is 1, but maybe it's negative 1. I can't quite read my note. And fill in these values. Okay, you're going to be using this table for the next 8 problems. Ooh, 9 problems. Nice. Okay, and then we're done. I promise. Can't wait until tomorrow. We'll do more of these. So here's your first question. Here's h of x is given to us as 5 f of x minus 3 g of x, and we've been told to find h prime of 1. Okay, h prime of 1. So in order to find h prime of 1, I need to find h prime and plug a 1 in. So here's h. How do I find h prime? Well, h prime is going to be the derivative of this. And yes, you can use the product rule, but I really wish you'd use that other one that says the derivative of a constant times a function is going to be the derivative of the function times that constant, 5f prime, minus, how do I take the derivative of this? Again, I could use product rule, but instead, I'm going to recommend doing, this is a constant, this is a function. Take the derivative of the function and multiply it by the constant. So we're going to have 3 times g prime of x. And since we want h prime of 1, that means we want 5 times f prime of 1 minus 3 times g prime of 1. Well, f prime of 1 is 5, so we have 5 times 5 minus g prime of 1 is 2/3, minus 3 times 2/3, and I end up with 25 minus 2, or 23 is h prime of 1. Okay, and just because I didn't write a sentence doesn't mean you don't have to write a sentence. I've already taken all my AP exams. You should not be boxing this in, and you should be writing a sentence. Okay, make sure you're writing sentences. Even if it's just the derivative is, h prime is 23. Be in that habit where all your calculus is in sentences. You'll be much happier. Okay, I think you know what we're doing now. So let's say that this time h equals 3f squared, 3f squared, and I'm looking for h prime of 1. Okay, give it a try. Come back when you're done. Okay, there. So again, I don't want to use product rule here. This is a constant. If I want to take the derivative of this, I need to take the derivative of that and multiply the answer by that constant. 3 times the derivative of that is going to be 2f of x. Leave the inside f of x function alone. Here, really, right? It's f of x is inside of that square. So there's my constant. I'm bringing down the power. I'm subtracting 1, so it's now f to the first. I left my inside function alone, and now I have to take the derivative of that inside function. Remember, this isn't h prime of 1, this is h prime of x, and h prime of 1 is going to be 3 times 2 times f of 1 times f prime of 1. By the way, a lot of students lose points on the AP exam because the problem, the free response problem says, find h prime of x and then use it to figure out h prime of 1. And what happens is students leave this step out. They go right to this. And then they've lost that point because the question explicitly said, find h prime of x. If you don't show them h prime of x, you just go for h prime of 1, you didn't do one of the things they asked you to do. So please make sure that, in fact, you read the question carefully. Like, yeah, I'm done. And then I go back and say, did I answer their question? Did I really? Because if I left out h prime of x, I did not answer their question. Okay, I need f of 1. F of 1 is 4. Oh, 2 times 3 is 6. Times 4 times f prime of 1, which is 5. And so we end up with 120. H prime of 1 is 120. So let's do a couple more of these, and then you can rest your head. How about h of x is defined in this curious manner? And I'd like to know h prime of 4. So before I do that, let's find h prime of x, and then we can find h prime of 4. Okay? Go ahead, give it a go, see what happens. I'm hoping that this is starting to feel a little more comfortable for you. Welcome back. So the derivative of this is going to be 10x. And now here, remember that this is g of x inside that cubic function, minus 3 g of x squared times the derivative of that inside function, g prime. So if I want to find h prime of 4, That means I'm replacing x's with 4's like this x. So I'm going to have 10 times 4 minus 3 times g of 4 squared times g prime of 4. Well, what's g of 4? G of 4 is 1. Okay, so I'm going to have 3 times 1 times g prime of 4. G prime of 4 is pi. All right, so it looks like my answer then is h prime of 4 is 40 minus, this was 1, this was pi, there's that 3 minus 3 pi. Okay, nice. H prime of 4, good. You can wrote it as a sentence. Thank you. How about this one? H of x is defined as f of x times g of x. Please find h prime of 1. Hey, welcome back. So when I thought about this one, I saw that and said, I gotta use product rule to find h prime of x. So f of x times g prime of x plus g of x times f prime of x. And remember, we wanted, in this problem, h prime of 1. So that means we want f of 1 times g prime of 1 plus g of 1 times f prime of 1. And it's really easy to take these values out of the calculator, off the table. 2/3 plus g of 1 times f of 1. Nope, that's f prime of 1. F prime of 1 is 5. So what do we got going on here? It looks like negative 8/3 plus 15. And you know, on the AP exam, this is h prime of 1. You can stop here. Just stop. Walk away. Do the next problem. I know you have this compulsion to like tidy this up. Make that common denominator. Combine those like terms and get 37 over 3 is h prime of 1. But on free response, stop here. On multiple choice, you're going to have to take it a little further. You're going to have to come up with h prime of 1 equals 37 over 3. All right, how about this one? Let's say h of x is defined in this manner. F of g of x. I'd like to know h prime of 4. H prime of 4. So, what's that going to be? If you haven't tried it, give it a try. What you should be noticing here is this is a function inside of a function. So this is a chain rule event. If I want h prime of x, I need the derivative of the outside, leave the inside alone, times the derivative of outside. And if I'm looking for h prime of 4, h prime of 4, then I want f prime of g of 4 times g prime of 4. G of 4 is 1. So g of 4 can be replaced with 1. And so now I want f prime of 1. F prime of 1 is 5. And g prime of 4 is pi. So I know that h prime of 4 is 5 pi. All right. Evaluate that composition with the table. Don't try and do f prime of 4 times g prime of 4. This isn't multiplication, this is composition. F has eaten g. There's f's distended belly. It's trying to consume g of x. The derivative of this composition is the derivative of the outside, leave the inside alone, not the derivative of the outside times the inside. Okay? All right. One last one? Sure. How about h equals g of f of x this time? There's our h of x, and I would like to know h prime of 1. So give it a try. Come back. I can almost guarantee you a table problem like this on your AP exam. All right. So h prime of x is going to be g prime of x, take the inside alone, times the derivative of the inside function, which is f prime of x. If I want h prime of 1, then I need g prime of f of 1 times f prime of 1. What's f of 1? F of 1 is 4. So I can replace this with a 4. G prime of 4? G prime of 4 is pi. And f prime of 1? F prime of 1 is pi. Ta-da! We now know what h prime of 1 is. From a table, no less. So we've got that notation. Dy dx can be dy du times du dx. We can think about the derivative as y equals f of g of x, and so then dy dx will be derivative of the outside, leave the inside alone, times the derivative of the inside. Okay? We know how to find these derivatives that require chain rule algebraically or calculusly. We also know how to use a table here to help us with this. In the last 2 years, AP Free Response have been asking students to compare two things. One is given in graphical form, the other is given in table form. Or one is given in table form and the other is given algebraically. So we definitely need to have all these connections and to be comfortable with all these things. Okay, do I want to take a look at that? I'm suddenly very confused. Oh, no, I'm good. Okay, sorry. Just thought I had suddenly done half of the next video's problems. No, I just got to the end of today. Hi, welcome to calculus. It's cool.